The Evaluation and Data Quality Control Team at the Barcelona Supercomputing Center of Spain shares the same vision and goal as the ESIP IQC, that is establishing and promoting community best practices for data quality. In the past year or so, we have made presentations at each other's team meeting or telecom. The team has recently been awarded the contract to support quality control function for the Copernicus Climate Data Store. Today, I'm very happy to introduce to you Carlos Lacanina to talk to us about their approach and planned activities for that contract. Carlos has a PhD in climate dynamics. He's experienced in evaluation and data quality maintenance of large data sets, including satellite observations and climate data output. The title of his presentation is The Evaluation and Quality Control Function of Copernicus Climate Data Store. Thank you, Carlos, for joining us today.
Thank you for introducing me. Shall I start the presentation?
Yes, please.
I put in full screen. You see the full screen, yes?
Yes.
Yes.
Okay. So this presentation is about the evaluation quality control function that we are building for the Copernicus Climate Data Store. So I want to remind you what is a Copernicus. Copernicus is, let's see, I put it here. Okay. Copernicus is the European Union's Earth observation program coordinated and managed by the European Commission. And the Copernicus provides unified systems through which vast amounts of data are fed into thematic information services. You see here we have 6 different thematic information services, and in our case we are focusing on the Copernicus Climate Change Service, named C3S, which aims at providing comprehensive information about past, present, and future climate to a wide range of users. Target users are policymakers, scientists, business, to achieve a more sustainable future. At the heart of the C3S, of the Copernicus Climate Change Service, is the Climate Data Store, the CDS. The CDS is works in a cloud-based infrastructure, so it provides a single point of access to a wide range of climate datasets, namely the satellite and the sea observations, reanalysis, seasonal forecasts, and climate projections. Those are present in many different databases in a cloud infrastructure and made available through the CDS to the end users through a web portal. So the user can go to the web portal and have access to all different types of climate datasets, which can be downloaded or can be accessed through a suite of software tools named the TOOLBOX that allow the user to visualize, access the datasets without really the need of any huge experience in how to handle large datasets. And also the user is the possibility to make his own scripts to tailor the visualization according to his needs, her needs. So as you see, such a complex infrastructure requires an evaluation quality control EQC function, providing an overarching quality assurance service for the whole CDS, the Climate Data Store of the C3S. The Climate Data Store is basically made of 4 components: the datasets, for which the evaluation quality control, the EQC, provides information about the technical and scientific quality and fitness for purpose, along with the independent assessment of the datasets, a sort of auditing of the datasets. And then the other component, the TOOLBOX, which is this suite of softwares that allow the users to play with the datasets without the need of downloaded datasets, for which the EQC, the evaluation quality control functions, assesses the maturity and the fitness for purpose of those software tools. And the other component is the service, so an infrastructure, the CDS, for which the EQC function checks the performance of the infrastructure in terms of speediness, responsiveness, system availability, and so on. And then, of course, the users, because the C3S, the Climate change service is a user-driven service. So we really want to assess the user satisfaction with the climate data store, and we want to map the user needs into user requirements that then are used to the further evolution of the CDS. So speaking about the first component, the datasets assessment. For the datasets assessment, we are defining a workflow. We have already defined a workflow for the assessment of the different datasets, leading to reports named quality assurance reports, for which the workflow basically works as follows. We have a fast assessment for which we check the compliance of the datasets with the set of minimum requirements that we identified. Then we have a more in-depth assessment if the dataset is already deemed of basic quality enough to go further in the assessment. For the in-depth assessment, we check we make a more scientific assessment, and we also check the maturity metrics of the datasets. And then this leads to the publication of these quality assurance reports, the QRs, which are organized in tables, homogenized, agnostic of the different dataset types. And those tables structure the information, the QC information, in a way that the user doesn't need to go through the whole PDF report, but the information is already structured according to the user needs selections. And then we of course have the user feedback that are analyzed for improvement, the expansions of both the CDS and the related QC information provided. So going a bit more into the details, the QC information provided is basically made of the documentation according to the provider indication about the dataset and reviewed by the evaluation quality control team, plus an independent assessment conducted directly by the QC team, which can be regarded as an auditing of the datasets. For the fast assessment part of the workflow assessment, the set of minimum requirements deals with very basic information about documentation, so quantity name, the units, format, and so on, and also an independent assessment regarding data checker. So if the dataset has physical ranges of plausibility, space-time completeness, and so on. For the more in-depth assessment, the documentation, we go more in-depth. So for documentation, we check the quality flags, the cloud masking, while the independent assessment can check for compliance with international standards and performance metrics and maturity metrics and fitness for purpose. As I told you, this leads both the fast assessment and in-depth assessment lead to the publication of quality assurance reports, which are organized in this table that is meant to be agnostic of the dataset type. And this poses a challenge because, as I told you, the climate data store, the CDS, encompasses a wide variety of dataset types: the satellite observations, the field observations, the analysis, the seasonal forecast, the global and the regional climate projections. So the challenge here is to provide a seamless and homogeneous QC information for the whole CDS datasets. For this, we introduced the synthesis table, which looks as follows. So when the user goes into the CDS portal, we have an EQC tab for which the user selects the variable of interest for the dataset and then clicks on the button to check the related EQC information. And then this web page is dynamically built that shows the main components of the QC information. So the introduction, how to access the introduction to the dataset, how to access the dataset, the different user documentation, and the dependent assessment, together with the selection and the basic summary of the dataset. Let's say in this case the user is interested in having an introduction of the dataset, so clicks on the dataset, and then, okay, I don't know if I'm still online, so I'm checking every now and then. And then once the user checks the introduction, then below appears this part of the synthesis table that offers different entries. So dataset overview, temporal spatial coverage, and resolution, and so on. So let's say that in this case, the user can be interested in having just an overview of the dataset. This, once the user clicks on this button of the synthesis table, the user is faced with the information related to the dataset overview. You see on the left side of this screen, you have again the different entries of the synthesis table just for the introduction part. And on the right side, you have the specific information about the dataset at the variable level. All this information is stored in a content management system. And then we move to the other component, the toolbox. The toolbox is this suite of software tools that the Climate Data Store makes available to the users to explore the dataset without the need of knowing exactly how to deal with the huge datasets. So the user can subset, arrange, visualizing the CDS, so the datasets, so the user can play with the datasets without downloading those. So the page of the toolbox is structured on 3 components. We have on the left side the workspace with the different software tools. In the middle, the editor, so the script that is for which is based the tools, and the user can actually modify the script itself. And on the right side, we have the results, which are basically often in terms of plots. Here, for instance, there is this software tool that allows to compare 2 different extensions of the polar Arctic sea ice from the 1992 compared to 2003. For which the evaluation quality control function assesses the quality of the CDS toolbox in many different multiple angles. Here we focus only on the software tools, and the software tools are assessed based on internationally recognized standards, ISOs, for which the software tools are checked for maintainability, usability, efficiency, and so on. And in particular, the evaluation quality control framework of the toolbox, so for the software tools, assesses the maturity of the software tools in terms of how much robust is the software in terms of code versioning, testing, and how much documented it is, and also evaluates the fitness for purpose of the software through use cases identified together with the users that checks the applicability of the toolbox to specific operations. So together with the users, we identify which are the software tools that the user needs, so to implement those in the toolbox of the Climate Data Store. So that you see information related to different software tools. So the evaluation quality control information that we provide as a function of the Climate Data Store is made available once the user goes to the specific software tool of interest. In this example, we have the input. The input is one of the basic software tool for which dynamic web page is dynamically built that shows the software tool for which there is a very tiny description of what the tool does and the inputs needed. The user is offered the possibility to click on to have a look to the related evaluation quality control information by clicking the button, and again, new dynamically built web page is built that shows a synthesis table for the software tools organized such that the user can see the documentation and description, or having a look at the code versioning and the different tests that have been conducted for that software. For instance, in this case, the user is interested in having a look at the outcome of the tests of the software. Going there, again, a web page is dynamically built that shows the information acquired during the evaluation quality control of this software tool. For instance, here, there is the maturity metrics for the different aspects of the software. So the availability, the appropriateness of the software, and so on. And the user is offered this possibility to see the work done by the evaluation quality control function. And again, all this information is stored in a content management system that is based on SQL database. And then the other component, the service assessment, so the infrastructure, because of course we need also to measure and report the technical quality of the Climate Data Store itself. So in terms of system availability, response time, and this is done based on key performance indexes, the KPIs, for which that are inspired by internationally recognized standard ISOs, for which we check the performance, the suitability, the reliability, and visibility of the Climate Data Store infrastructure. This is done in terms of these KPIs, the key performance indicators. We also monitor, along with the infrastructure, we of course monitor also the user satisfaction. This is done through rating widgets. So for instance, the user just finishes the work with the TOOLBOX web page. At a certain point, a rating widget appears that asks the user to rate his satisfaction with the responsiveness of the TOOLBOX page. So the statistics acquired through the rating widgets and the key performance indicators is then absorbed and made available through a dashboard that is under development, showing the different aspects of interest for both the infrastructure of the climate data store and the user satisfaction of the climate data store. And of course, the fourth component, the user needs. As you see, the user are all over each component of the climate data store because they're central for the C3S, the climate change service, because it is a user-driven climate service. So the user feedback is central to develop recommendations for improvement and expansion of the climate data store, different components, the datasets for the toolbox and the service itself. The first, on the right-hand side on top, you have the different users interested for different components of the climate data store. The user pool ranges from climate scientists to societal end users, each of them interested in a different aspects of the climate data store. It can be the datasets, the toolbox, or the infrastructure itself. And this user pool provides feedback that we acquire from different channels. We have a specific focus group or a few people that we continuously interact with. We go to the workshops. We have the help desk tickets that we acquire. We have specific emails and so on. All these channels are needed to gather the user feedback, and then those are collected in a database. And finally, the database is analyzed to provide the URAD. So I cannot manage to move this away. Okay, great. So the URAD. So those URAD are those reports that we analyze to further develop the CDS. And this slide is to show that we have many commonalities with the ASIP IQC. We bring together different communities to assess the aspects of the quality of our science data. We establish baseline of standards for data quality and for adoption by data providers. We promote the data management standards and best practices for ensuring high quality data for use in climate policy and services. We strive to have data quality harmonizations, as the synthesis table shown you, and the user guidance and data conventions are fundamental for the development of the Copernicus climate data store. Also, the maturity metrics and the promotion holistic approach are central for our view, and we are very happy to give a presentation in this meeting. So to conclude, what I've shown you, that the evaluation quality control function for the Copernicus climate data store, the CDS, provides an overarching quality assurance service for the whole CDS. Different components, the datasets, the toolbox, infrastructure, and the users. The climate data store contains a wide variety of datasets, satellite and seed observations. It realizes seasonal forecasts, global and regional climate projections. Then there is the toolbox, this suite of software tools is available to explore and visualize the datasets. So the user doesn't need to download the datasets and doesn't need to have a huge knowledge about how to handle large datasets. And then the users can fully understand the status and the purpose of the data product with all relevant information in one place. So the synthesis table, which is based on the methods that the user deems most important. So instead of facing long reports, those reports are split in different entries, boxes of the synthesis table, for which the user can just easily access and find information of interest. And the synthesis table also works as a homogenization of the evaluation quality control information across all datasets, which allows them eventually to directly compare several different products, even for different dataset types. The evaluation quality control function provides guidance also for the data providers on the information they need to deliver and how to be compliant. And the users, of course, are central for the development and expansion of the CDS. And then DATASET, IQC, seems for us as an appropriate place for discussion of the different IQC aspects. I leave you with the last slide of the different questions that we have. If you want, we can discuss them further. Okay, that's it. I want to thank you for hosting this presentation. This is our service contract in the Barcelona Supercomputing Center for the Copernicus program, which is operated by this ECWF, the European Center for Medium Weather Forecast. That's it. Thank you.
Thank you very much for the excellent presentation. I agree, and about the ESIP IQC, a good place to convey, exchange information, and discuss potential challenges and solutions. And I'm looking forward to continue communication and collaboration between the two groups.
Any questions?
This is Chong Ling at Goddard. Can I have a question?
Yes, please.
All right. Okay. Thank you, Carl. It's a very good presentation. I have a question about your, indeed, it's very good. You have all kinds of data sets, satellite-based, in situ, and or even as part of the analysis. Can I know how many data products you have over there in total? Or how many kinds? Like 1,000 or several hundred?
We are speaking about several hundred. The fact is that the CDS, the Copernicus Climate Data Store, is becoming operational. It started to be operational during last autumn 2018, and at that time there were in total, I would say, 20 data sets, but it's growing exponentially. So now we are around 100, and it's continuing to grow because all the providers have already been contacted. Now we are at the moment where the data sets are coming to be public in the CDS. So that's why we also have an evaluation quality control function that is setting the minimum requirements so that the data sets are also of basic checked of basic quality before being published. The fact is that the evaluation control function started just later, and some data sets are already there without being evaluated yet, but there's another story.
And should I assume all the data sets supposed to also contain the DOI?
The contain what?
DOI, the data index.
Digital object identifier.
Yes, each that here contains the DOI. Yes.
All right. Okay.
It's
so
even by the Copernicus instead of the dataset itself by the provider.
All right. So so when the user using this toolbox, can they even have some of the say ask questions if they have encountered some problems and you have a service to reply to them to help them to resolve the problem?
Yes, if you go in the portal, we have indeed this self-help desk. There is one, actually is one of our main contributors, user feedback. We usually we get so many tickets from the help desk that are used in our user feedback analysis. Yes.
So your metrics also measure how many users in a daily basis or monthly, and also how many files been distributed and how big the volume of them in total distributed, right?
Yes, indeed. This is what they will be. When we measure the user satisfaction, we indeed gather these statistics from the key performance indicators and the rating widgets. So where the datasets are downloaded and how much. All these statistics made available through a dashboard, which is under development. So we have it internally. So we see at the moment it's not yet public. So what you see here is really preliminary. The numbers are also really not the ones correct numbers, but it's to give an idea that we are monitoring already those things.
And you also mentioned about the visualization tool. So actually, if users come over, they can probably simply just do the window shopping. They don't even need to download the data if they don't see the data is what they need. So they even can can kind of draw up some plots out of the data, just like
Yes,
right? Okay.
Yeah, that's the challenge indeed, to hide the user, the need to know about the format, the different structuring of the data set. The challenge for the climate for the Copernicus Climate Change Service, the CTS, is indeed to make a common data model that is able to restructure the data sets in such a way that can be offered to the user without the need of knowing about the format and how the data sets are structured. So the user can really face different data sets without the need to download them. For us, it's really challenging. Maybe it's one of the most challenging things which is hidden in the infrastructure.
Yes. Okay. Thank you very much. Thank you. That's it.
Thanks.
I have a question. How often do you survey users and for their user satisfaction, and how often do you do that?
Okay, so as I said, apart from the ready widgets, that when this will be operation, this will appear every now and then once the user has to enter this the website. So for this we have I don't want to, maybe hourly measure of the user satisfaction, but for the other things like contacting user through the workshop, so every 2 months, let's say, we have a focus group, so and 20 users that are continuously updated about any release from the climate change service. For those, we contact continuously through teleconferences or through emails. So this focus group is continuously contacted once there is a new release in the CTS. But also we have the help desk. So also all these tickets are continuously assessed as a user feedback. We also link with other contracts in CTS. We have a dedicated mailing list for this, so the users can directly provide us feedback. And we also, as an evaluation quality control function ourselves, we are also super users of the climate data store. So we also actually provide ourselves feedback to improve the CDS. So how often is difficult to say. It depends on different channels, but can range from hourly to 2 months, I would say.
Okay, thank you. Let's see, I had one more question. I forgot what it was. I'll come back to it. Let somebody else speak.
Okay. Well, I have some questions, so I put them here. Maybe somebody knows.
Sure.
Yeah, apart from the things that, like the first question, that for which we need the users. So what type of information, the data sets are the users interested in? For this, we contact the user, but also we are not aware of any list of minimum requirements to assure a minimum quality of the data sets at our best knowledge. If anybody knows how to answer to those questions, just raise the voice. And we don't know the users what they expect, the granularity. We had long discussions about where the evaluation quality control information should be shown, which granularity level. So at the variable level, at the dataset level, at the version. It was a long discussion. At the moment, we are at the variable level. And the frequency of updating the evaluation quality control information. So what can be automatized, because based on to what extent the evaluation quality control function can be automatized, then we can also define a different frequency of updated information that we provide. How to devise a scoring system informing about the level of the dataset information available. And the lack of the standards for climate data and metadata quality standards. If there are any maturity levels defined for the evaluation quality control function itself. So we also understand as a function providing the quality information, at which level we are and where we have to go. If there are any maturity metrics for the modeling out of the datasets, because there are there is a number of maturity metrics for the observations and the analysis, but it's difficult to, at least at our best knowledge, we found just one maturity matrix, which is still at the research level for the climate projections. So for us, is important because we deal with many different data set types. I want to give an homogeneous evaluation point control function. So having a maturity matrix or devising maturity matrix is agnostic of the data set type would be great for us. And also, are there international standards similar to GCOS that could be applied to modeling data sets apart from the CMOR and these CCI? But I mean, those are different standards compared to the GCOS. And then the gaps in the standardization of terminology, processes, and practices due to a lack of an appropriate regulatory framework. I mean, for us, all these are really open questions.
Yeah, I now that you put this up, I remember what my question was. Are you using ISO 19157? Are you familiar with that standard?
Can you repeat it?
ISO 19157. That's the ISO standard for quality, data quality.
Data quality, but not climate data, is true?
It's not specifically for climate data. In general, for quality of data and how you record it. So it's the specifications that you need to have these kinds of different kinds of metadata and how do you store it and so on. That's what ISO 19157 covers. And ISO 19115-1 and -2 cover the standard for metadata in general. And there is the Climate Forecast Convention for Net CDF CF convention, and that's quite widely used. You're probably familiar with that. Yeah. So I think the CF
for the GRIB format, we didn't find any standard. Actually, it's weird for us because it's a World Meteorological Organization that promotes the GRIB files format, but for us, it's weird that there is no standard. There is one for NetCDF, but not for GRIB.
Okay. But the principles of CF, I think, apply more generally than to just NetCDF, I think.
Yes, we checked it. Indeed, the principle applies. We would have been happier if there was already a certified standard, but for us, yes, thanks for the other ISO you pointed. I will check it. Thanks.
Okay. And the other question I had was, you're familiar with the inventory of ECV?
Yes.
Essential Climate Variable Inventory?
Yes, indeed, the C3S, the climate data store is started with those and now is expanded to non-ECV.
Okay, okay.
So for those that are mostly from satellite, there is a clear standard, which is for us the CCI standard. It's the one that we recognize as standard we check against for all these data sets. But for the other data set type, like a seasonal forecast, for us is a bit more difficult to find a clear standard, probably because those data sets are not mature enough. And what a real challenge was also gathering together different communities that usually in climate don't speak often together, like a satellite community together with the regional climate projections, with the seasonal. I mean, this is was also difficult at the beginning, but now we are much more working on the same page.
Right. Go ahead.
Can I share two penny about the Carlos question? Probably I can combine those. First, you say what type of information data sets are the users interested in, and the third one, what is the level of granularity expected by users? I probably can't convert this one to another question. I will probably ask from our perspective, just say, well, how kind of what kind of service we can provide to the users, then they can quickly, I would call efficiently, means to quickly and properly get the data they want. Usually when users come to our website, they don't, sometimes even they just kind of just window shopping, they even don't know what they want, but they do have something in their mind. I'll probably share some experience with you as from our data center here. Several years ago, I come up with an idea called a data bundle, because I'm personally a research scientist are doing a hurricane. So when I go to a data center, I want to get the data needed to study my hurricane. So I can start with that. And now we have a data, we evolve into a data list. So perhaps, I will say this. So for your data center there, you have probably you provide, many data sets different from different products, but serve the precipitation or serve the winds. Then probably, and also the different level of granularity could be level 1, level 2, even reanalysis. So you probably can kind of set up certain aspect for users when they're looking for certain features. You can list a bunch of data sets related to the features, and also different level of the data. Let the user to decide. They can pick. So instead of just, well, you have so many data pop up to them, they even need to search, right? So sometimes you probably have some keywords for them to say, if they type, of course, we are using climate here, it's not a hurricane data here, but you say energy, water, and energy budget, then of course you need to have the data heat frost, you would need to have the wind field, and you have the precipitation field. So probably that's in that way, you probably can serve actually what the data the user probably interesting. I'm not sure if that would be helpful somehow.
Okay.
Yeah,
well,
I think so. And along that line, I like to add a comment, because I think these two items 3, item 2 and item 3, they probably depend on, the minimal quality requirement or level of granularity really depends on our application.
Yes,
indeed. Yes.
Okay, so you mean the fitness for purpose. So depends on the use case, and then of course the user is interested to a different level of granularity.
That's correct.
Well, I probably say, well, the user come over, they probably have some in their mind, certain interested topic, a scientific topic they want to research, they want to do study, or even like Hans mentioned publications, disaster or whatever. But of course, this is climate data, even climate data. We can serve certain function. Different subject. Which user may be interesting. So if you also can set up certain category, and for those category, when user click on those, then you'll guide them to all the data available for the user to study this particular subject. That's what I mean here.
Okay.
And of course, you can list all the level 1, probably start level 2, level 3, and level 4, and you all put in the same packet there, and let them to choose. Even just like so when you do subset, you have data there, right? They don't have to download the entire data set. They can subset in time. They can subset in variables, right? So because some products like Mara 2, I'm not sure. Of course, that's your ECWF one. So they all the different variables, all contained in the same data files. Then you even allow them to subset only part of the variables instead of they need to download the entire product.
Okay, for us the granularity for the evaluation quality control function of the granularity problem is at which level the information about the quality control should be given at the variable level, dataset level, and so on. Then the user can be interested to, depends on the application, can be of course interested to even subset the variable. But for us, for providing the use information, we were wondering at which level we should make it available.
Well, I think it depends on, of course, it depends on the users. And some people just want to know, is the data good or bad or excellent, or needs a lot of work and that sort of level of detail. On the other hand, somebody who is doing research may want to have pixel level data quality, or what's the uncertainty at pixel level. That's the granularity some people will be looking for. So you probably need to cover a broad spectrum.
Wow, that means it's difficult then how to deal with the frequency of update and this information, because if you go so much into details, even at the pixel level, that means that as soon as there is an update of the data set, we are already outdated. So it's then difficult to go.
A particular given data set is going to be created and it'll be there for a while until the data are reprocessed. So I would think that the pixel level quality is going to be automatically generated rather than somebody looking at it manually.
Yes, for the satellite data set, it's true that it would take some years for the update. The problem is it's for the seasonal forecast that those are updated every month. And for us, it's really tough to get on time for providing the case information for those frequently updated data sets.
Okay, we're sort of running out of time. If there is any burning question, somebody can ask. Otherwise, we're going to go to the next parts of the agenda. All right, not hearing anybody else pipe up, I'm going to go to the next part of the agenda here.
Okay, thanks.
Thank you very much again for providing an excellent presentation in the live discussion.